Welcome to this video on Dijkstra's algorithm. We will walk through a step-by-step demonstration of how it works to find the shortest path in a network. In this scenario, you play the role of a mail carrier, starting at town A. You need to deliver letters to every other town on the map. Your goal is to use the numbers on the roads, which indicate the distance in miles, to figure out the shortest distance from town A to each of these destinations. Before we begin, we set the initial distance to 0 for our starting point, town A, and mark all other towns as having an unknown distance, which could mean infinity if you like. Our goal is to update these values as we explore the graph. First, we mark A as solved. From A, we can reach neighbors B and C. We calculate the distance to B as 7, and to C as 9. Currently, B has the smallest distance, so we will focus on it next. Now we solve B. From B, we update its neighbors, D, E, and C. The path to D is 17, and to E is 11. We look at the connection to C, but since 18 is longer than the current distance of 9, we keep 9. Now C has the smallest distance. We will focus on C next. Moving to C, we update its neighbors. We look at E. 9 plus 5 is 14, but since E is already 11, we keep 11. We also find a path to F with a distance of 21. Now E has the smallest distance. Next we solve E. From E we update G to 14 and H to 19. We also check B and C, but they are already solved. With these updates, G now has the smallest distance. With G solved, we check its neighbors. The distance to D is 20, but D is already 17. The distance to H is 19, which matches our existing value. We note a tie for the path to H. Now we solve D with a distance of 17. Checking from D to G, we see no improvement, since G is already 14. We now look for the next smallest, which is H at 19. We solve H. Checking from H, the path to F would be 26, which is higher than 21, so we do not update. H also connects to already solved nodes. F remains the smallest at 21. Finally, we solve F. Checking neighbors shows no further improvements for any other nodes. All towns have now been solved, completing our path exploration. Here is the final summary of the shortest distances and one possible path for each town starting from town A. This demonstrates the efficiency of the algorithm in finding optimal routes. It is a simple yet powerful way to solve this type of problem. Now, choose a new starting point, such as E. Can you find the shortest paths from E to all the other places? Give it a try and you can do it.